All right, that was so much fun. Let's do another one, but let's do it faster this time. We know the idea, the setup of it. This time, let's just look straight for what we're solving for. We're looking for nitrate anions in this case, okay? And we're starting out with sodium nitrate, and let's just do it all, okay? So nitrate, it looks like this, right? NO3, and it's a -1 charge. Well, the number of moles of that is going to be equal to the solution, 54.8 milliliters. It's going to be a little laggy here because I'm uploading the last video I just recorded on the subject, times 1,000 milliliters in a liter, okay, in 1 liter, and 1 liter is going to contain 0.122 moles of sodium nitrate. All right, now this is where things get a little bit trickier on this problem. Sodium Na yeesh, nah, okay, wait a minute. Sodium nitrate, NO3. Actually, this isn't where things get tricky yet. It's the next piece of this problem where it's going to be a little bit more confusing. Whoa, nice huge eraser there. I'm just moving this over to make it easier to read. 1 liter times, okay, now for every sodium, which is a 1+ charge, right, there's going to be 1 nitrate, which is a 1 negative charge. That balances out, so really it's just 1 to 1 like this. Didn't even need that here, and I'm going to solve for that later. Let's set up the other one now while I've got momentum. I'm going to say that the nitrate, yuck, bad color, yuck. Let's go. Aesthetics are going to slow me down more than anything. Okay, let's go nitrate anions in the second solution. I've got 13.1, right? Make sure I remember that decimal point there. That's your job. Okay, 13.1 milliliters of this times 1 liter over 1,000 milliliters. I guess if you wanted to start out with this in liters to begin with, it'd save you a little space, but you might make a mistake if you're like me. Okay, and the concentration is 0.294. Okay, 0.294 moles of this was copper nitrate. Okay, I'm going to leave a space there. NO3, because we don't know what's really going to happen yet. So copper nitrate, what does that look like? Well, copper, if you look, well, it could have a couple different charges, but we're going to say it's copper 2 nitrate. Okay, so not going to change anything here, but if it's copper 2 nitrate, then this is going to require 1 more of these, right? Because this is a -1 charge, each one of these. That makes a total of 2 negative if I'm writing it in the right format, right? And this is 2 plus, and now it's balanced. So let's do this. That's 1 liter right there, right? And I'm going to multiply that, and now what I want to do is say, well, for every 1 mole of copper nitrate, this is getting sloppy. Think about a drawing tablet as if you shift it, it changes everything. Okay, so there we go. Now 1 mole of this is going to contain how many moles of these? Well, maybe it'd help if we come up here and we write out what happens to copper nitrate when we break it up. Copper nitrate, that's a 3. Okay. 2 of those. In water, you might see it like this, yields a copper cation, right, which is 2 plus, well, we said it was going to take 2 of these, so it's going to look like this, 2NO3, and that'll give us our 2 negative to balance out this molecule. So there are 2 moles of this for every 1 mole of this. There's 1 mole here, 2 moles of nitrate. And nitrate's what we're looking for, right? So NO and 3, okay? And we'll just have to do the equals down here below. Let's see, that is, well, actually we haven't done the math yet. Let's do the math for both of them. Alright, so this first one, 54.8. Oops. 4.8. Need to hone my 10 key skills and speaking. Okay, divide that by 1,000 to get liters. Let's move it over here. I think I'm going to do a bigger screen next time. 0.122. Okay, and that 0.122 was how many moles per 1 liter. Okay, that's also the molarity. So I'm going to multiply that out, and my answer comes out to 0.00668, or 0, we're just going to say 0.00669. And remember that I said in the last video that you know, on OWL they like to keep it at 3 sig figs, whether that's the right thing to do at the very beginning and every step or not. So we're going to do it their way so we get it right on their program. So that's going to be that many moles of nitrate. Okay, not remember to write that there, NO3 negative. Okay, the next one out. I hate it when it happens. Okay, so the next one is going to be 13.1. I'm not going to show you this. I'm just going to do it off screen. 13.1 milliliters. Okay, divided by 1,000 milliliters. That's right here, right? Actually, I will bring it in. Okay, times the molar value, which is 0.294. And times the molar ratio, which is 2 to 1, so that's going to be 2 times. And my final answer on this half is 0.0770. Okay, so we'll just write it right here. 0 equals 0, 0. This is what gets me 0.770 to 3 sig figs, right? Moles of nitrate. Okay, now we need to add them up, right? And again, on OWL they like to round at every step, so we're going to round each of those and add them together. So we've got 0.00669, and I've got 0.0066. Oh, I must do the same one twice. 77. Oh, that's interesting. 7. Okay. Maybe not. And we add those together. There we go. And that gives me the number of moles of nitrate is equal to 0.144. Now, if you're doing this anywhere else, you would not round at every single step. It's just bad form. Moles. And that's going to be divided by the total volume. Okay, so let's figure out the total volume now. We've got 54.8 milliliters, and we've got 13.1 milliliters, and we're going to add those together. And that gives us 67.9 divided by 1,000 to put it in liters. And that gives us, I didn't write the answer down here. Let me, hang on, let's go back here. Is that what I wanted? Yeah. 1,000 point, or excuse me, 1,000 divide. All right, and then we're going to say this is our volume. Okay, so 0.0679 liters, and the final answer to this is going to be this divided by this, so 0.144. Okay, I'm going to swap those, and then I'm going to divide them. My answer ends up being 2.12 molars of nitrate anions. And that's that. It actually took longer. Oh well. Good luck. Mostly to me, I hope.